A lot of hot water here in Yellowstone. And what's it powered by? A magma chamber beneath the surface. Turns out we know an awful lot about this magma chamber too. It's one of the most studied magmatic systems in the world. Scientists have bounced seismic waves off of it. They've done seismic and electromagnetic imaging, sort of like taking an MRI of the Earth to see the properties of this magma chamber. And it's revealed quite a lot about the way this system works. Now, when we draw magma chambers, it's usually sort of a red balloon right under a pointy mountain. It's not really what they are. It conjures this image of all melt. But in reality, magma chambers are complex mixtures of some melt, a lot of solid crystals that have precipitated out of that melt, and even some gas, sort of like the carbonation that comes out of a soda. And based on all these studies at Yellowstone, we know that the magma chamber is about 2.5 miles beneath the surface. And it's mostly solid. It's only about 20 or so percent, give or take, molten. And those molten lenses are stored in various horizontal layers within that chamber. So not a lot of actual melt in the Yellowstone magmatic system, but it's still hot. It's enough to heat water that circulates down there and give us the spectacular geysers and hot springs that we see behind us today. Well, that's the story of Yellowstone's magma chamber. Now let's talk about the earthquakes, deformation, and geyser activity that occurred over the past month.
During the month of May, earthquake activity remained at background levels in the Yellowstone National Park region. The University of Utah seismograph stations located 119 earthquakes during the month. Most of them were in this area between Hebgen Lake and the north-central part of Yellowstone National Park, as is usual. Now, there were 3 swarms just to the north-northeast of West Yellowstone, Montana. That's also a pretty common area for swarms. And the largest event of the month was a magnitude 2.7 that occurred on May 26, just north of Yellowstone Lake. Turning now to ground deformation, this is vertical deformation at the Lake GPS site on the Sour Creek Resurgent Dome, the east side of the caldera. This entire plot spanned 2 years, and each one of these blue dots is 1 day worth of data. Overall, we see a trend of subsidence of about an inch or so per year. That's been ongoing since 2015-2016, and it's interrupted in the summer months by a pause or a brief amount of uplift, and that's caused by runoff from spring snowmelt. So no real changes in deformation of the caldera. Steamboat Geyser has not shown a whole lot of activity during the month of May. It had its last eruption in April, and since that time we've seen in the temperature that's measured in the geyser's outlet this sort of daily temperature variation that indicates there's not a whole lot of water in the runoff channel. So it doesn't appear that there's a lot of activity at Steamboat this month. We'll have to keep an eye on that and see if it changes, leading to perhaps a major eruption sometime this summer. And finally, the new webcam at Biscuit Basin, site of a hydrothermal explosion back in July of 2024, recorded a small eruption. And that occurred on May 31st at 8:39 p.m. This is the first video recorded eruption since last July, although monitoring equipment and eyewitnesses have recorded several smaller eruptions. So the new webcam at Biscuit Basin already paying dividends.
Well, that does it for the YVO monthly update. Now remember, if you have any questions at all, feel free to email us. Our address is yvowebteam, all one word, at usgs.gov. Stay safe, stay healthy. We will see you next month. Bye-bye.